Okay, I'm surprised that so many are here, right? So it's the first session after the party, and Thiago is in the other room. I was kind of expecting to have like an empty room here, then I would have like added another hour of sleep, but no such luck. Okay, so application scripting. I think I said I'm working for KDAB. I'm also a KD developer, and yeah, I'm also working as a Qt trainer. So some of you I recognize from the training day on Monday. Welcome back. Application scripting. So application scripting has a number of applications, right? So we can use application scripting to automate workflows in our applications. We might want to use that as a way of being able to add plugins later on, make plugins downloadable in a way that does not depend on the architecture or the binary system of the user. Right? With C++ plugins, we easily run into binary compatibility problems. It's of course solvable, but an interpreted plugin has certain advantages. Application scripting can also be a very powerful tool for users, right? If you make your application scriptable in a way that the user can provide scripts, then the user can automate their own workflows. We know that this is very widely deployed with Office products, for example, right? The Visual Basic for applications is one of the most widely used languages because it allowed people to automate workflows with Microsoft Office. And something like that might or might not be also interesting for your products, right? It's one of the important use cases of application scripting, right? One of the nice features about scripts or script languages is, as I said, they're interpreted, so they are not only independent of the binary situation of the user, they can also usually be reloaded, right, at runtime. So if you don't have any state in your script, reloading the same script can just start again, right? So sometimes you don't need to if you load a C++ plugin, unloading the plugin might not always work, depending on where you have objects that the plugin created. Okay, so just as an overview, we have a couple of options here. Qt comes with a couple of script engines itself. There is the now deprecated QtScript, but I'd say it's still one of the most complete solutions that we have in Qt. Right? It has been with us for the whole Qt 4 series, has been extended, and there is tooling around it and so on. There is this new thing, the QJSEngine, now also the base for QQml Engine, right? That was kind of like planned as the successor. It is not like a fully compatible solution to QtScript, doesn't have the same API, but yeah, it's still a very powerful JavaScript engine. Of course, there's also external solutions. Lua is one of the most widely used scripting solutions out there. It's easy to create Qt bindings for that, but of course, since it's not built in, right, you have to create bindings for that yourself. But still, it's a widely used language. Scripting thing, there's also all kinds of bindings for external libraries. There is a lot of examples on the internet, so Lua is also usually a very good choice for a scripting solution. Then, of course, the really advanced languages, right, like Python, they come with own class libraries and whatnot. There are professional bindings for that for Qt, right? PyQt bindings and PySide, and so also good solutions. And there's probably numerous others, right? All these scripting languages have one way or another to bind to binary languages, be it through a C API or directly binding to having interpreters where you can register C++ objects. Okay, what I'm going to focus on in this talk is the QQml Engine. So one of the options that is built into Qt or available with Qt as a standard module. Well, wait, what? Right? QQml Engine. right? There's the QJSEngine, QtScript. Why would I want to use the QQml engine, right? What if I don't need any UI, right? Yeah, I don't need any stinking UI. I just want to automate my workflows. Well, yes, QQml does not have any UI dependencies, right? What you're probably thinking about is QtQuick. Right? QtQuick is the UI framework that is using QML to provide a new way of creating user interfaces. QQml itself is totally independent of any UI. As I will show later on, I have several console applications that only link Qt Core and QQml, right? So using QtQml does not incur any UI dependencies if you're afraid of that, right? It does not incur dependencies on OpenGL or something like that, which QtQuick does. Then you say, right, I want to have simple JavaScript scripting. I don't need the declarative programming. Right, true, right? QtQml Engine is obviously primarily designed for declarative programming. But as I will show, we have a very simple way of just running a simple script with basically a fixed boilerplate wrapper. But of course, if we do not do declarative programming, we're missing out on a lot of things. Also some I will show. Okay, so right, QQml Engine, not the most obvious choice in the set of available solutions, but this is basically what I wanted to talk about today, showing what we can do with QQml Engine that might not be very obvious if you thinking from a strictly scripting point of view. Things that you might find valuable enough to consider QQml Engine as the scripting solution of your choice. Right. As I said, you're missing out on a lot of things if you do not do declarative programming. Okay. As I said, for those of you who are just simply interested in a very, very simple, in basically just using QQml Engine to run a JavaScript file, right? That can easily be done with a fixed boilerplate code. So the QQml Engine requires that whatever we load is a QML file, right? Or QML content, QML code. So what we do is we provide very minimal QML code for the engine to understand, and we use one of the features of QQml. In QML, we can import a JavaScript file, and just like this, right? We have one line, we say import, then we provide the URL to a JavaScript file, and then we define basically a namespace, right? The JavaScript file has a couple of functions, and then we provide a name that's like the name or the object, namespace or object for the functions inside that file. So very trivial, right? What we see here, we have a simple function that says, okay, run JavaScript. It basically gets the file name of a JavaScript file. I also optionally allow here to specify the main function, so that the function that will be executed, right? We have a JavaScript file has can have any number of functions. This allows us to specify with which one to start, right? Which one to execute first, basically. I will also have this in a real example. This is just a slide to discuss how to use the QQml Engine for simple the straightforward scripting, right? So I just passed the URL of the JavaScript file as my first argument here, and the function as my second argument. And we see our QML here declares a Q object, right? So the basic type in QML is a Q object. We define ourselves a property, and the function's result is stored in that property. That's all we need. That works basically for all kinds of JavaScript files, right? We just need one function to execute, and if it returns something, that will be stored in the result property. Then we tell the QML engine to create a component for us based on this code, right? Set data. So we just create a QML component that's part of our boilerplate code. And then we create this object. This line here creates this Qt object, right? The QML API has things we can check if it's ready, if there were errors, and so on. If there were not, if the component is ready, if the object was successfully created, if there were no errors, then we just retrieve the result property. So at this point, basically after create, our JavaScript function has been evaluated, and we can retrieve the result, right? all we need, right? From the outside perspective, if we were running that, if we were calling that from our application, all the application programmer or the user of the script runner would see is a function where you pass in a JavaScript file and a function, and it basically, well, I could return the value, right? So that would probably be a good addition here. Right, so still very simple, but as I said, if you're using the declarative, if we're doing declarative programming ourselves a bit, then we can do a lot more things. Okay, what do we get already with this? So the QQml engine, this is why I picked it for the topic of this talk. It comes with a lot of built-in features, right? Things that, let's say, its base class QJSEngine does not have, right? These things that are built into the QML part of the engine. We have includes. So by default, if you, for example, even if you use QtScript, there is no concept of including one script or have a script include another script. This is basically you have to implement it yourself. You have to provide your own function that goes into the file system, loads the file, and adds it to your interpreter. This comes built in Qt, so you can just use qt.include in any JavaScript file that is running inside the QQml engine, and it will include that script. There is a global Qt object that's also inherited from QML. It has a lot of interesting functions. For example, you can quit the application from there, right? It's basically sending the quit signal of the QML engine. You can, so it's quitting the engine, not the application. So sorry for that. It has functions to, for example, create a color based on value. So it's a global object that has a series of very useful functions depending on what you do. For example, it has a function to open an URL in an external program, right? So if your script wants to open a PDF in the user's PDF viewer, you just call Qt open URL, what is called open URL something, and then this will go to the operating system, and then the operating system will launch the correct application for whatever file you pass. So the things you get basically for free. QML, since QML was primarily constructed for working with UI, right? The QML engine itself doesn't have any UI dependency, but that was the design goal initially, right? Using it for Qt Quick. So there's very easy access to data inside the applications. It's also easy to access objects that are already instantiated on the C++ side. We can easily access all the properties of such objects. We can directly call slots on those objects. We can connect to signals of those objects. We can even call Q-invocable methods. So it's a very, very nice way of making API of your application available to the script. It's basically very, very simple to do that, right? You have already the objects on C++ side. You just export them in a very easy way to the QML engine, and then you have it available in your script. I will show an example for that. Something that is a bit lesser known, the QML engine can intercept URLs. So when there is different use cases for that. One I will show is basically you can make sure that only scripts, let's say, from a certain prefix are loaded, or you could even restrict that, say, only scripts from the resource system can be loaded, right? Or from certain sites. You can allow whitelist sites that allow to be used as JavaScript sources. Yes, and just like the global Qt object, it's very easy to provide your own global objects. It's basically what QML considers a singleton. Okay. So these all are available when you do just the simple script that I showed here, right? So these are all available just because we are inside a QML engine. As I said, if you do just that, you're missing out on a couple of things, right? So what are those things you're missing out on? Right. So for example, you're missing out on the basically all the classes, all the types that are available in the QtQml module, right? Let's say this is almost like a standard library, right? JavaScript doesn't come with any standard libraries. It basically has math, it has state, and that's about it, right? There might be a couple of other types, but there's a lot of types here in the QtQml module that you can easily use if you just do more than the boilerplate programming in the declarative world. For example, there is a timer class, right? Very easy to do. You have a script that should do something in regular intervals. You don't have to export a timer from C++. You just instantiate the timer in QML, right, in your own QML code, and you have access to a timer with the full capabilities of QTimer, right? You can specify an interval, whether if it's just one time, whether if it's continuously running. You can start it, you can stop it, and so on. You can import other QML modules, right? There is, for example, a module that contains models, right? The XML list model, for example, is very nice for prototyping. You can easily extract data from an XML file. The list model allows you to inline define lists of data. Things that were, of course, intended to be used with UI, but they're still available. If you want to, right, if it's okay for you to depend on QtQuick, you can even use stuff that is in QtQuick but doesn't necessarily show UI, right? There is elements in QtQuick that are helper classes, so to speak, for the UI, and they do not involve UI themselves, but you can also use those. Right. And of course, you can make your own modules. So the whole QML system is based on runtime loading of modules. So let's say you have a very wide script API. You want your scripts to be basically able to do a lot. Then you don't necessarily have to build this into the application. You can split this out into modules, and if a script requires that module, it will be loaded automatically, right? So you can ensure that if a user does not run like the advanced scripts, then their memory will not be consumed by stuff that the user doesn't need. So only scripts that need those modules will load those modules. Bindings. QML, right? QML is all about properties and bindings on properties. So if you haven't had a look at QML yet, this is basically the most important thing about QML is bindings on properties. So you have objects, object export properties, and then you have expressions that depend on several properties and calculate values of new properties. I also have an example for that. For scripting, this is a very interesting. It's interesting for scripting because you can automatically trigger function calls based on value changes, right? So you have application data, input, whatever, and you want to run certain script functions whenever values change, right? You could do that. You could have an object that would emit a signal. It's like, the value has changed, and you would connect to the signal. And in that basically function that is connected to the signal, you would reevaluate whatever you need. With bindings, you can write this way shorter. Basically, you just have the values as input arguments of your function, and the QML engine will automatically call your function when any of its inputs has changed. Also very nice. Okay, obviously, right, if you're using QML, we have access to UI if we want to. QtQuick, for example, right? This is the most obvious choice when you're using QML for UI, but you can also use widgets. The QML engine can basically instantiate anything that is a QObject-derived class, right? And all widgets are QObject-derived class. So it's only a matter of registering those widgets that you want to instantiate. So if you have a widget-based application and you want to allow your scripts, for example, to create tool buttons or combo boxes or whatever, right? And then you can allow that, right? They just will write that like QtQuick UI. They will basically have a toolbar element, and inside the toolbar element they will position tool buttons, and the script will have full control over the state of these widgets, like when to enable them, how to react to clicks on buttons, and so on. So UI is an option, right? I don't say you depend on that. It's something that you can decide to do. And a lot of applications will use scripting in some form with UI. Unfortunately, I didn't have time to prepare an example for that. But it would be easy to do. Right. And we can easily instantiate our own types, because in QML, QML basically is intended for creating objects of types. And one thing that might not be very obvious, doing that allows you to create types basically on the fly in scripts. or like subclasses of register types, right? Which is very useful for mocking objects for tests, for example, right? Or if you have separate teams, one team working on the UI, one working on libraries, and you have interfaces defined, and you would otherwise have to create mock objects in C++. You can easily create the mock objects using the engine, and then your UI team can already work with objects that even provide data with signals and slots and so on. I also have an example for that. Okay, so I promised all kinds of examples. So I think just doing slides for a technical talk doesn't just cut it. So I will now switch to my laptop and show a couple of examples on what can be done. Okay, so right, so this is the script runner I already showed, right? This is the full version. The slide only had like part of that. Like here we also just dump the errors. So the QML Engine, if there are any errors, I can just dump them. I could of course show them in a view, whatever, right? So it just has, I get information on like parsing errors and things like that, line information. So the API there is very nice. But just as on the slide, there's really nothing to do, nothing more than that. The only thing I do here is I have always the fixed same code, and I call that basically from a very simple main function, right? I have a console application here. As you can see, it's a QCore application. I just take the file name from the command line. Potentially, if I have a second argument, I take this as the function to execute inside the file, and then I just call my function. So if in case I do not specify a second argument, I just assume that main is the function inside my script file. Let's have a look at one of those script files. Right? Of course, the most important thing for any kind of programming example is a hello world example. So here I have a function hello world. That's a JavaScript function. It just returns hello world. It doesn't do anything else. So I call that hello world, and hello world is the function I want to execute. Right? So hello world is the hello world.js is the file, and hello world is the function I want to call. Right? And the result it returned was as QString hello world. Right? This is the property. This is the property I retrieve from here. Right? This is the property, the result of the property I retrieve here, the result of the function. Of course, I could also print it inside my file. That's actually what I'm going to demonstrate next. Okay. So one of the nice things that QQml Engine also has is it has built-in logging capabilities. Right? This is what's needed for QML. So it's also available for us here. In a standard clean JavaScript environment, we have no way of writing to standard output or standard error and so on. Here in QML, we have a console object that has log, error, warn, and so on. Right? So if as you can see, I have a main function here, so I do not need to specify that. Hello log, right? And I get the printout from Qdebug, basically saying hello world. Console. Like console object is one of the global objects that is available at all times. Okay. I also promised that it is easy to access like application data, right? Let's see which one that is. I think that's this one, right? To do that, I need to slightly modify my script runner. So as I said, it's easy to export basically objects that you already have on the C++ side. Let's see here. So, right. Here I just export the Q application object. Right? It's very simple code. So basically I have an object already. I can export any type of Q object, right? Any type of Q object. I just say, okay, I provide a name that's like the console name as you saw in the earlier example. That's just a name to address the object, and then I provide a pointer to the object. And then I have access to all the properties inside the object, to all the slots that the object exports, to all signals and so on. In this case, and in this simple example that I have here, I'm accessing the application name property. Right? QCore application has an application name property, and I'm just reading that here in my script. Yep. Of course, I have to rebuild after I've uncommented the line. See, that's the advantage you have with scripts. You can just modify the script and run it again. Okay, as you can see, hello from and the basic runner is the name of the executable, right? The name of the application, just retrieved from the C++ object. Right. Let's see what we have as well. I think if you just have a simple value, right? So this was basically access of an object. But sometimes you just have a simple value, a fixed value that does not change. Same thing, right here. I also export the URL of the script itself. Same thing, set context property, provide a name to access it from JavaScript, and then just the value. So basically, the API here is using QVariant. Anything you can put into QVariant can be passed here. Of course, the JavaScript side still needs to understand the type. This is a string, of course it understands the string. So, or in this case it's a URL, it also understands the URL. So, right. I have access to my script, easily access to my script URL, just by exporting the URL object. Yes?
Do I also have access to the children of the Q object?
Of the Q object? Yes, I think so. Okay. I think I have another example. Let's see. Platform. Right. So, as I said, sorry, question.
Some examples with the slots and connecting with slots.
Oh, I don't have an example for that here, but so basically the slots you can just call. So, for example, for the Q application object, you could just say app dot and then any slot name like a function call, and then it will execute the slot. For the connect, I'm sorry, I forgot about providing an example for that, but right, it's basically just the object name, the signal name, dot connect, and then inside the parentheses you provide the name of the JavaScript function, and that function will be called whenever the signal is emitted. Right. This is also just for as an extension. I said there is this global Qt object, and it also provides information. For example, here it has information about the platform. I can easily like check in my script which platform I'm on. Right. Then it says I'm running Linux here, right, which is of course true. Why would I run anything else? Right. So okay. So this is basically the most basic form of scripting. Right. We have a fixed boilerplate script QML code that just runs the script. And as I said, inside the script, I have another example. The include thing. I also said this comes with built-in include capability. Right. This Qt object has an include function. I can easily include any other JavaScript file here. Just Qt.include. So it comes with built-in include capability. And then I just call the function. Yeah, it's just for the reference. The code says hello world. It first executes the hello world function that returns hello world, and then it just adds included afterwards. Right. So this is exactly the string I get here. Okay. So far, very basic scripting. Right? I can run any kind of JavaScript file. I can specify which of the functions I want to run first. Its result is immediately available in this wrapper property. I can include any kind of other scripts. I have access to certain functionality like easily exporting objects, easily exporting data. I can I can do all kinds of things with the global object, like checking the platform. So the Qt object, just let me look at it in a Qt. Right, so it has all kinds of functions for handling certain things, like a function for creating MD5 hash or something. Right, so translation functions, for example. Right. Okay, so now to the point where I said, okay, what if we don't just do the boilerplate code? What if we do a bit of declarative programming ourselves? Let's see. I have a very similar thing like this script runner. I call it a QML runner. Right. So the QML runner is slightly different. Here I only have a file name. I create again a component. So this is now a QML file, so I don't need any boilerplate QML. I load the QML file. I again check if it is ready, and when it's ready, then it just keeps running. So in this case, we do not just execute once. So basically, we have the script running. It's now a component in our application, so it can do all kinds of things like event process. The call to the object created method here, this is just empty in this class. I just needed that for other examples. So in subclasses, I do things with the object. Okay, so, but again, very simple thing. I create a QQml endpoint on my engine, and I create the object. That's all I need to do. And in case of error, I can again have access to the error. Okay. Right, so a script for that would look like this. As I said, right, we now have access to all kinds of things in the standard library. For example, a timer. Creating a timer in QML is really trivial, right? We just make this timer, like we just specify that we import QtQml. We use the timer element, and then we just fill the timer with our values. So I set this here. I have an interval of 500 milliseconds. It's repetitive, so it fires continuously. I start it by default, and I even use here a local property, a counter, right? I just have a local variable here, and say after 10 counts, it will just like quit the engine, right? And I probably can show that as well. If the engine quits, I quit the application. This is just for my example program, right? So of course you don't need to do that in your application. You might not allow scripts to quit the application. So just quitting the engine. Just demonstrating that. We'll run a. You see the output. The timer fires every 500 milliseconds, and after it reaches 10, it just quits. Again, very simple QML file. Right. So, but now I did a bit more declarative programming than just my boilerplate. Of course, here I did everything inline. Right. The block we see here in the on trigger. This is JavaScript. I could call any JavaScript function here as well. Again, I can import my JavaScript file on as a second import line, and then like call functions. Right. This is just the most basic example here where I do everything inline. You can call any of your JavaScript functions. Like using a switch, depending on count, you call a different function, for example. Okay, so this is just one of the examples for using the declarative approach. So if I look at the bindings, right? I said bindings are one of the most important things to do. Right. So what I do here, maybe I just run it for once. And so just that you see what it does. This is very, very simple UI. Basically, my use case here is I have 3 sliders, and those should calculate the color, right? and I want to export this calculation of the color to script. So I don't want to do that in C++ code. This is something that should be customizable. But color is a very simple just example for having multiple input values. And I want to be able to calculate that with on the script side. So how do I do that? I again have my runner here. That's a subclass of the QML runner you have just seen. I use that to export another context object, right? So I export this as the result object, and I have a function to allow the UI to set sliders with a name. Right? If we look at that on the main window, the main window basically it's a standard QtWidget application. It registers its slider with the names green, blue, and red. Right? And then it reacts to the changes, right? The color changed, and then it sets that on a label, right? Okay, so the widget part is not very interesting here. Let's see how one of the scripts look. Right? So the most basic one I called normal color. So what I do here is I first normalize the values. I just create local properties in QML. Say, okay, this is the RGB values. There's between the slider is from 0 to 225, so I just normalize that to 0 to 1. And then I use one of the built-in functions to generate the color, right? And then I basically report back the result by assigning it to the property of this result object. Again, this is a very simple example, so I'm using a built-in JavaScript function here, but you could call any function inside and import a JavaScript file, right? This is important to remember here. Just because I write here qt.rgba doesn't mean I could not call one of my own functions. I can easily import one of my JavaScript files and call my own functions. The thing I want to demonstrate here is that I have basically a function with 3 input values, right? And of course I want to have that function re-evaluated whenever one of those values changes. And declarative programming does this for me. If I run that, right, and I move one of those sliders, it changes the color, right? And I do not have to react on signals or something because that is built into the QML engine. So if the QML engine if the QML engine sees a change of the value of one of those sliders, so the sliders notify listeners with the value change signal, right? Actually, I moved the red slider and red.value will change. QML will automatically update the R value, right? So it knows that the binding has changed, it updates R. R changes, so QML knows it needs to re-evaluate that function. So if I have a function that recalculates values based on inputs, I can easily do that without having to connect to signals, right? In this case, I do not have to connect to 3 signals and then always call the function. I just, use the declarative approach to say, okay, I want this function re-evaluated whenever one of those value changes. Just as another example, slightly more. Okay. So I say, okay, I only want to use, basically I want to only have the color opaque if any of those values is beyond a certain threshold, right? I just say, okay, if this, if any of those values are greater than 0.5, I just use opacity of 1 and otherwise 0. So if I run that, whoops. Color does not change until one of the sliders reaches basically. Oh, sorry. The color does not change until one of those reaches the threshold, right? And again, my function is re-evaluated whenever it's necessary. Okay. So bindings, right? As I said, bindings, QML is all about bindings. We can use that to basically automatically trigger function evaluation when we do scripting. Okay. Let's have a look at the more important thing first. As I said, we can do basically define objects or define types in QML use our own things. So the application I have here is very simple. It basically says, okay, I have a UI that has a line edit, and the line edit should show the temperature of a temperature sensor. And my main application only knows about the abstract type of my sensor. So the abstract type is defined as a QObject. It has a method to retrieve the temperature, and it has a signal to tell me when the temperatures change. Typical form of a sensor API, right? Usually it's a bit more involved, but this is what sensors would look like. So I, as the application developer, now want to test my application without having to wait for our module developers to develop temperature sensors. So what I do is I create a small wrapper. I call it a QML sensor. It just provides API for QML to interact with that type, right? So I can just change a value from QML. Similar to, oh, I haven't shown that yet. So what I do is I register my type here. I register my QML sensor type with the QML type sensor. And here I use the onObject created override to cast it to my sensor and emit it to the main window. Code using that looks like this. Let's see. Right. So the most simplest, of course, mock object is one that just has a fixed value. So here I just import my sensor module. This is the type I just registered. I create an instance of my temperature sensor, and I have a fixed value. Right. So. Right. And I have the value I have, right? So I could just easily change that, 25, rerun it again, I have 25. Right? So this is really easy to basically create an object. It is an object of the type I am expecting, because the QML type engine just instantiates objects, right? So, but of course I can do better, right? Having a simple value is not that interesting. Let's say I combine what we saw earlier, right? So I have a temperature sensor, and I use a timer to drive the temperature, right? I just have, again, the same thing, a repeating timer, and I just increase the temperature every time I run, the timer runs out. Okay, right, okay. This is already more useful, right? So we now have an actual change. Our application, we can check that our connection to the change signal is correct, that the correct value is read, and so on. But since we are in QML, and yes, QML has access to certain, let's say, classes that were intended for UI usage, we can abuse them, right? So. Oops, sorry. Look at this. So one of the things we do in QtQuick and UIs is we use animations, right? And since QtQuick is QML, and QML is all about properties, all those animations animate properties. So nice for us. Our QML sensor has a value property, so we can use animations to change the value of that value property. So what I have here is basically a sequence. First, I have an animation that changes the value, right, from a low value to a greater value, and then the other way around, down again. And I can specify different, durations, how long it takes to change to the range. Even this is linear, basically interpolation. This is a curve interpolation, so it starts lower, then accelerates in the middle, then slows down. You can do all kinds of things with that, right? So it was intended for UI usage, but we can still use that. The only thing I have to change here is I import QtQuick. Demonstrate that. So I now have a temperature sensor which basically bounces between 15 and 20 and uses different ways of calculating values for the upslope and the downslope. Could easily use that, for example, to check if I do threshold checking, right? I want to generate a warning or switch a warning sign on when the temperature goes beyond a certain point, but I need to go below a different point to deactivate it again. I can easily test it with such a mock object. Okay, thank you, Q. Okay. Yeah. So I have a couple of more examples, but I appear to be running out of time. Maybe just show the code for the other one. I don't have to run it. So one of the things is that it's URL interception. So this is the API of the engine. I can set the URL interceptor, and my URL interceptor in this case is it's very basic. Just basically, whenever the QML engine tries to load something, a QML file, a JavaScript file, and so on, calls this function if it has an interceptor. So here I check, okay, if this is a file URL, and the path that is passed in is basically below the script path, so it's a child path, right? It's a child path of my script path. Then I accept it. Otherwise, you know, I create a warning, I could create an error, and just return an empty URL, right? So I do not allow the script to load any of those files. There is another application for that, slightly different, also coming from the QML world. Also just showing the code here quickly. Let's see, where is it? File selector. There's a thing called the file selector. QML file selector is using the intercept pattern to rewrite URLs. So for example, it allows you to do, you specify a file and you can load different files on different operating systems without changing the file name, right? So the QML engine does that for you. Or you can load a different file depending on the locale you're in. You can load a different file when you are in an English locale or a German locale and so on. Also allows you to specify your own things, so you can specify basically a debug selector, and then you can load different files if you're in your debug mode, right? Without changing the actual script, right? Your file, in this case, it's just show the file. Where's the QML file? Right. So this is the file we would be loading, right? And then I use this own selector mechanism that I can use. I have a debug directory plus debug plus the indicator for this file selector thing. And if I have my debug system on, I'll just load this file. So it will always try to find the most accurate file automatically. So if I switch this debug flag on, it will load this file. And this one has debugging, like trace logging inside, right? So without the application changing anything. The application will just load HelloWorld.ts. But depending on my system or my locale or any kind of application-specific flags that I want to have checked, it will try to find other files. Right? It will try to find the most specific file for my request. Okay, just to sum up, I would not consider using QJSEngine directly. That's just it's just way more convenient to use the QQml engine. They are in the same module anyway, so you're not saving any dependencies. Both of them are in the QtQml module. And a QQml engine has a lot of nice additions, right? Additionally to the just scripting that you can do a lot if you just basically willing to invest a bit into the declarative programming part, like the bindings, like those objects that already exist, right? And okay, right. Consider declarative programming. Any questions? Yes.
For custom type, you can export in QML or
yeah.
You provide kind of intelligence, or completion during script.
Okay. So the question is, if you export a type, does Qt have basically have autocompletion for that? I think it might need at least that you recompile the application once so the code model gets updated, but I think it does. So if you register types, it should have access to the properties of that object. Yes? Can I run two scripts at the same time? Yes, for example, my QML script runner, I could create just two components and they would be loaded as two top-level components of the engine. I can always, of course, also instantiate more than one engine. In different threads, okay, sorry. Yes, the QQml engine it does not have any UI dependencies, so you can just run the QML engine in a different thread. Right, it just creates QObject instances, and QObject instances are fine with running in a different thread. The moment you use QtQuick, right, then you're going into the UI domain, and Qt has this concept of not running any UI out of the main thread, but as long as you do basically non-UI stuff, even using like timer objects, things like that, you're fine in a different thread as well. Yeah? I think currently not. So since KDE is building up or like growing from old versions of Qt, right, and also adapting, most of the scripting in KDE I think is still based on QtScript. Right, you have a huge code base that uses QtScript, so it's difficult to port away from that because the script engines are very different. Okay. Yeah?
If, assuming you're stuck with Qt 4.8, is there something preventing you to use a similar approach to deprecation instead of QtScript?
Sorry, I did not answer the question.
So it seems that you could do something similar by importing QtScript and making all the components of that.
Right.
Just asking if there is some reason why you cannot do.
Okay, so I think the question is if you only have access to QtQuick 1 basically you're on Qt 4 basically, right? Yes, you can use the QtDeclarative engine in very much the same way. So the QtDeclarative engine is basically also in QML engine. You can do almost the same things. Since it's QtDeclarative always has UI dependency because it was just intended for QtQuick, right? So they did the separation with Qt 5, but you can do all the things that you've seen here also with the declarative engine.
Will QJSEngine be deprecated or?
No. So right.
Right.
No, QJSEngine is basically the base class of this one. So it's definitely needed. It just doesn't have QQml Engine doesn't add any explicit API, it just has lots of things built in. So I still expect QJSEngine to evolve over time. So since they now deprecated QtScript, right, with 5.6, I think that people will add API, like C++ API to QJSEngine that you can use alternatively to the QML approach. It's just saying that if you just look at QJSEngine, you might like say, okay, this is not usable for me. I cannot do anything with that. That's just not providing me with enough API for scripting. But QQml Engine usually does, just in a slightly different way. Okay. Excellent. Thank you.